yesterday's program which we discussed about, and here we are adding these null values, and we have seen the corresponding output as duplicates were not allowed into this set, and we have seen the corresponding output as well. Order which we cannot predict because it's a random order of collections when it comes to the hash set as a generic type. Why we have to use integer here over int? Because int is a primitive type, but collection definition says that it is a collection of objects. So to go for object type, we have to create the object for a classes. Therefore, classes are allowed to use. Integer is a class for int primitive. So we have listed yesterday. That's the reason behind we have to use mandatorily wrapper classes only. If you are going for integer, what will happen? Is it because of only left side? I'll change right side also. What happens? Compile time error. Read the error. Multiple markers at this line, syntax error, insert dimensions to complete reference type. Yeah, that's the error, and we know the correction. Here is the correction. So this is one hash set demo. I'll use the same package to create the next example. That is nothing but linked hash set demo. Linked hash set demo. Considering main method, click on finish. So inside this linked hash set, first I am creating the object. What to import, please? Import java.util.linked hash set, and here we just remember the names, standards, and also proper casing here. Otherwise, you'll get the compile time error. L should be capital, H should be capital, S should be capital, no spaces in between. That is even Java people also have followed the classical naming standards for the classes. And to create the object, I'm using linked control space, linked hash set. So it's a generic type. Default any IDE will suggest you to go for a generic type only, because it is programmed in such a way that non-generic types will have a no type safety, so that we'll face some problems once we are going to use such type of collections. That's the reason it is always recommended to go for generic type only. And to understand this order, I'll go for first integer kind, then we'll go for one more example of characters. So integer, I'm using LHS is my object variable, new control space, and here again integer type. Mandatory or optional we'll discuss later. First, let us understand the basics. How to add the elements into this linked hash set. The object variable dot add method. So inside this add method, I'm trying to add some numbers, some 20, and again adding one more, some 10. Next LHS dot add off, this time say 100, and one more say LHS dot add off, I'll take 1. Yeah. And let me save here. Next, how to print this? System.out.println. You can use the object variable called LHS. What is the expected output? Which order? Insertion order. List linked hash set is a property of insertion order. So if you don't want the order and without duplicates, go for hash set. But without duplicates, if you want the order, then we should go for the linked hash set. So for this, what's the order? 20, 10, 100, and 1. So this is our expected output. Let us cross verify. Control yes, control F11. We got the same. So this is the property of a linked hash set. Can we add duplicates? Can we add duplicates? Yeah. So LHS dot, again I'm adding wantedly a duplicate. So for example, 100. Will it accept? Do we get in the output? No, because any of the set doesn't allow duplicates. It can be any of the implemented classes as well. This property is applied. Next, can we add null? So LHS dot add off null. Can we add one more time? Can we add one more time? Yes. Do we get in the collection? We don't get in the collection. So control V. I'm adding this duplicate value once. Now also I'm adding null as a duplicate value. After this again I'm printing. So two print statements will get two outputs LHS. If you save and execute, what is expected output? 20, 10, 100, 1 null as the insertion order without duplicates. This is the next second output. What is LHS here? What is LHS? It is one of the collection object. Can we add this entire collection into one more collection? Yes, we can add. So for that, I am creating the syntax of object for this LinkedHashSet once again. Copy this, paste it here, and I'll change this from to LHS2. So to this to this new collection object LHS2, let us add some more elements. LHS2 dot add of a different value from the previous. I'll take 2000. One value I'm adding because it's an integer type. Then we have a previous collection. What is the previous collection object? LHS. So can we add the collection object? LHS dot add which one? Add, you can see first one integer, second one integer, what about third one? Collection, and next one collection only. So here I'm using this add all method to add the existing collection object variable called LHS. Yeah, so for LHS2 dot accepted, right? Now what should be the output if we print LHS2? LHS2. What should be the output? 20, 20 to 100. First, which one we are adding? Then followed by LHS2. Then what should be the output? 2000 first element because insertion order is placed out, right? So first 2000, then followed by the LHS object data again in the particular order. So this is about one collection elements can be added to another collection. So let me write that point here. One collection can be added to another collection as well. And here is the output. Please take for your reference. Can we remove a particular element? Yes or no? So by using which method? Remove method. So now here I am using LHS2 dot a method called remove one of such elements. Let us remove some 100. Is it there? Yes. So after this removing, I'm going to print the same LHS2 only. Now let us observe the output. Control F11. So what's the output here? In the previous LHS, 100 is there. Now since we are implementing the remove method on this previous collection object, therefore from this new list, 100 is gone. 100 is removed. Can we remove the entire LHS from LHS2? How to remove? LHS2 dot remove all is a method. There we have to give the collection object LHS. Save it. After this again I am printing LHS2. What should be the output of last line? Only 2000 because after removing this LHS, what is there? Only 2000 will be there. So let me save here. Let me execute. So this is the example of all the methods that we have, and you just practice. You just create this object and dot implement each and every method for your practice and cross check with the corresponding outputs. Size and length, sorry, size, retain all, and easy to empty. All those methods you can implement it. This is an example of LinkedHashSet from my end. We'll go for next TreeSet. Then I'll use the same package to discuss next example. New class, that is TreeSet demo. Inside this, I'm taking the main method, and here is a TreeSet demo.java file. Again, here also you have to import. You need to import anything? Yes. What do you have to import? Import java.util.TreeSet. Next, I'm going to create the object for this TreeSet type. So TreeSet generic type. Let us go for integer kind of example to understand ascending orders and all. Then later on, I'll talk extensively on this TreeSet because there is so much to understand. TreeSet TS equals to new TreeSet, again a generic type integer. Yeah. Next, how to add the elements? TS dot again add some values. I'll take some -1. Possible or not? TS dot add of some 100. Next, TS dot add of some 5. I'm just taking some jumbled order so that we can notice the default natural sorting order as an insertion. So I'll go for 1000. Yeah, that's it. So these are some values which I have taken to this TreeSet. What is expert output? System.out.println use TS. What's output? Ascending order means smallest. Which is smallest? -1. Next 5. Next 100 followed by 1000. So this is our expert output. Let us save and execute. So we got the expert output. So here is a TreeSet property. By default, it is a natural sorting order. Can we add null? TS dot add of. I'm going for option of null. Accepted. What will happen once we execute? Do we get any order of output or do we get any exception? Exception. What's the reason behind exception? Null is not to be compared with any of the values. So during that comparison, we'll get an exception called as null pointer exception because that is the last line of code. So when JVM is executing that, it is unchecked exception. So we got null pointer exception. So it means null is not possible to add along with some other objects. I'm writing my point clearly. Can we add alone null? Alone null. Yes, we can add. Can we add duplicates? Can we add duplicates? TS dot add of. I'm asking adding means do we get any compile time error? No. But do we get the output? We don't get the output. Let me comment this one to understand the point of duplicates. Execute. So we got 1000 only one time, even though as a programmer we have added twice. I'll roll back these changes. Let us see by adding only null as a individual element. By removing all the remaining things, I'll just change that. Control is TS dot. This time I'm taking add of null. Do we get the output or error? Output. System.out.println print TS. Save it. Execute it. What happened? What happened? Only as a single element also we got the null pointer exception. From which version onwards? From Java 1.7 onwards. I'm clicking on Windows button on my keyboard. I'm typing CMD, enter. And to understand the version, I'm typing Java minus Java space minus version. What's the version which I'm using? 1.8. So because of that, even adding one single element also will throw the null pointer exception only. If it is a previous version, then we get the output as null element as a single value. Combination of values, even at this point of time also, will get the exception. Sorry. Exception even the without any version change. But if it is from the version 1.7, even adding one element as a null also will give a exception. Till 1.6, you'll get the output. If you want, you can just cross verify if you find a version or if you know how to change the versions. So please do take for your reference. To understand the for each loop support for each of these collections, let us come from HashSet again. So I'm commenting this previous print statement. If you remember, what is a for each loop syntax? Yeah, for object, which object type? Which type of collection it is? Integer. Next, programmer defined variable name. Let me go for some variable X which is not used in this. Then colon. What's the collection name? HS. So inside this for loop body, how to print it? System.out.println print HS. Sorry, print X. Save and execute. What's what we got? Some random order of the output. Even though our order is 100, 200 followed by null, but by using this for each loop also, we can print the collection elements. This is a support which we are getting from generics, that is Java 1.5 version of this. This is the purpose of for each loop action. Just to print the collection elements in the given order from starting to ending without any initialization, without any condition to check. We can print n number of collection elements which are present. This is the second approach. First approach is directly print statement. Second approach is by using the for each loop. Even same thing for linked HashSet also. Yes, so we'll write the same syntax here. Can you please tell me? I comment all the previous print statements to see only for each loop for this. And this remove also I'm just commenting because let us have the elements. Remove also have commented. So we get the entire LHS2 data with the help of the for each loop concept. Can you please tell me the syntax? For type of objects, integer not int, next program defined variable, then colon array name, or sorry, collection name LHS2. So inside this system.out.println print variable name called X, save and execute. So we got the insertion order of the output, that is 2000 is the first element into LHS2 object, then followed by previous collection 2010 1 none. So this is the second approach again, even for linked HashSet as well, with the help of the for each loop support. Next, same thing. Let me take from here, copy. I'll back to TreeSet demo. I'll comment the previous print statement. After this, I'll paste this integer type, only the name we have to change the collection name. Yes. What's output? Same output that we get with normal print statement as well. What's the difference that you notice? Yeah. So previously when we print by using a print statement, internally all these collections will call toString method that will always print the output in the square brackets only. But when we are using this for each loop, then because of this println, no square brackets and we get each element in new line because of this println. That's one difference. But the order of output is same for the corresponding HashSet, TreeSet, linked HashSet, the same order of output, but in a different ways. One more interesting point from this TreeSet. So this is already TreeSet demo. Let me copy and I'll go to the package. I'll create a new class. This one I'll take the TreeSet demo 2 with main method. Click on finish. So again, I'll create the same syntax of this TreeSet with the import statement. We can use the shortcut for this one. TreeSet. This time I'm going with a generic type of string. String kind of objects I'm going to add. Again, the object variable name ts equals to new TreeSet demo. So no TreeSet. And again, I'm taking the generic type here also as string type, and I'm using semicolon, and we have to import it. This is the normal story which we are aware of. Then to add elements into this collection, what type of elements are allowed? Only string type. So let me take some ts dot add of. So one of the string is, say, for example, Java. Then I'll copy the same line. Copy and next line paste it, and paste it. I'm taking some 4, and this time from Java after I'll go for J2EE, and then I'll go for some HTML, and I'll use CSS. So what is the output that we get if we execute this program? All of you please. What is the order of output that TreeSet will print? Default natural sorting order. So what is sorting order for this names? Name starting with C and then followed by H, then 2 or J, and after A will come, right? Then E will come second. That is what we are expecting. Correct or not? What's output? Same thing. So this is for a string. Yeah. Please do it. Regarding TreeSet only, I'm taking this one more example. I'm taking one more file called TreeSet demo3.java, and here import statement we have to add it. I'll use the IntelliSense for that, and then inside this I'm creating the object. I'll just copy paste from this. And here I'm using ts dot add of, all of you just please, new which object I'm trying to add, which object. You can see here. So if I take some Java here, accepted. So I'm making this generic type of string builder, and even right hand side and left hand side of syntax as well. And I'm trying to add string builder object called Java. So let me copy this and I'll go for. So first I'm taking same output as, same input as Java, JEE, then followed by some CSS, some HTML. What's the order of output that we expect? What's the order, please? Previous output only, no? What's the order? CSS, HTML, Java, JEE. Then here also I'm just printing the object variable name. TS. Let me save, execute. What's output? What happened? Exception, we got it. What's the exception name? Class cast exception. Yeah. So for this, we have to understand something internally. What is the reason behind why TreeSet is throwing exception when we try to add this string builder object? For integer data, fine. Float, byte, all those are fine. And even for string also fine. But when it comes to string builder, so because of some internal properties of this, TreeSet will not add this string builder objects in the default natural sorting order because of comparison is not possible. Comparison not possible for internal reason. That's why we are getting exception called as class cast exception. This is a point to be noted. Please, I'll tell you the reason, but please do take and especially mention that it is a string builder object, not every time. To understand the reason behind this one, we have to understand the next concept, which is a lengthy concept, but I'll make it as short as possible. So there are three cursors are there. In Java, there are three cursors. So first again, what's the meaning of this cursor? What is a cursor when it comes to system language? I'm using my cursor here on the screen. What's the meaning of it? To point to a particular line, I'm using the cursor of the system. I'm pointing this, for example. Similarly, in collection also, a collection is nothing but it is a group of objects. If you take any collection, it is a group of objects, say object 1, 2, 3, 4. Some objects were there here. Yeah. Then which by using cursor, we have to point this. Okay, print this one and print this element or print this object or print this object. The cursor has to point this internally these objects so that the cursor will print that particular element. Because of the cursor is pointing that, then the corresponding methods will print the corresponding object as output. But because of this cursors internally, what is supporting and what is not supporting, so there is no support for this string builder objects with a default or universal cursor. That universal cursor is nothing but iterator. And one more cursor is enumeration. And one more cursor is list iterator. These are the three iterators that we have in Java. So there is a specific reason for why three are there. So as of now, today I'll just give you the glimpse of what it is what. In tomorrow's class, we'll discuss why it is not accepting for string builder, why only for string and also all the primitive types, why not for string builder. When it comes to this cursor enumeration, this is applied on only legacy classes. Enumeration as a cursor, which is applied on only legacy classes. We know the examples of legacy classes, vector and stack. So this is applied on only those two. If you try to apply on the new versions of this set and list and maps, then we'll get a compile time error. Enumeration is not applied on the other versions. It is applied on only legacy classes. That's the first point. This iterator is called as universal cursor. What's the meaning of universal? It can be applied on any of the collection objects. This iterator is applied on any of the collection objects. That is the purpose of this iterator. Because of some iterator limitation, the next one is introduced as a list iterator. This will be applied on only which one? Array list. Or list, we can say simply list. Okay, both array list and linked list as well. You can say simply list. There is a reason behind why list iterators is required. I'll discuss in this list concept clearly. What are these? These three are cursors. Are they classes? Are they interfaces? Are they methods? What? These three are interfaces. So indirectly, one of this is used in this one for comparison purpose, and that comparison is having internally some other method. So because of that method, so we are getting this class cast exception because that doesn't have a support of string builder objects. One last point for the day. Yeah. The last point is string builder objects are doesn't have a support of comparable. Doesn't have a support of comparable. Comparable is one interface. This much only just remember. If you get a cross question only, all these points you have to answer. Otherwise, just simply learn and ignore. So because there is no support of comparables for this string builder objects, that's the reason behind why we are getting this class cast exception.